So we've been looking at the Newton's second law. It deals with force, mass, and acceleration. We've looked at an extension to this, universal gravity. Gravitational force is equal to the constant g times first mass, second mass, divided by the distance squared. So, a little quick review. What acceleration would result in 12 Newton net force on a 3 kilogram object? Anyone tell me? Number 1. So what acceleration would result if you applied 12 newtons of force to a 3 kilogram object? And Michael, put your mask on. 4 meters per second squared. So a net force of 12 newtons causes a mass to accelerate at 5 meters per second squared. What would be the mass? So a 12 Newton force causes a mass to accelerate at 5 meters per second squared. You're close. 3.2 kilograms, right? 3 and a fifth. How much force is needed to accelerate a 66 kilogram skier at 1 meter per second? So force is equal to mass times acceleration. So it would be 66 times 1, or 66 newtons. What is the force on a 1,000 kilogram elevator that is falling freely at 9.8 meters per second squared? That'd be 9,800 newtons. So again, if you look at number 3, you could write it as 66 kilogram times a meter divided by a second divided by a second. But if it's in kilograms, meters, and seconds, you can replace all of that mess with N for Newton. No. So there are various forces in the universe. There's 4. There's gravity. This is the force between objects of mass. A force is just a push or pull that causes a change in motion on an object. So gravity will pull you and force you down toward it. Anything with mass has gravity. You have the electromagnet magnet force. It can be broken up into electricity, which is the force of electrons. So whenever you turn on electricity, it's forcing the electrons to start moving. We can also have magnetism. So if you take a paper clip next to a magnet, the magnet will pull the metal toward it. So it'll be the force of magnetism. We also have friction. Friction is an opposing force that causes things to slow down. The 4 main types of forces are just gravity, electromagnetism, weak nuclear force, and strong nuclear force. We won't get into the nuclear forces in this class. Now, this brings us to the third law. For every action, there is an equal and opposite reaction. So Newton's third law, for every action, there's an equal and opposite reaction. So yesterday, when we were doing examples, I talked about your weight being a force caused by Earth's gravity. So Earth pulls down on you with a certain force. This is equal to your weight. According to the third law, you also pull the entire Earth upward equal to your weight. It's the same force. Because for every force or every action, there's an equal and opposite force or reaction. So I think I asked this. I not asked it in this class. I might have just only asked it in the second, the other two classes. But I asked, which pulls stronger? Does the Earth pull more strongly on the Moon, or does the Moon pull more strongly on the Earth? And it's the same, because for every force, there's an equal and opposite force. So you're standing on the ground. Earth is pulling you down, equal to your weight, but you're not flying to the center of the Earth. Why not? Because the ground is pushing upward on you. And the amount of force the ground is pushing upward on you is equal to your weight, and so you have a net force of 0. It cancels each other out, and hence you don't move. So there's always going to be an equal and opposite reaction for every action. So according to Newton, whenever objects A and B interact with each other, they exert forces upon each other. When you sit in your desk or chair, your body exerts a force downward on the chair, but the chair also exerts an upward force on your body, keeping you up. If the chair did not, so what if you sat on like an empty cardboard box? The cardboard box can't exert a strong enough force to keep you upright, so you crush the box and fall down. Y'all need me to go back? So, third law. There are two forces resulting from this interaction. A force on the chair and a force on your body. These two forces are called the action and reaction forces. The action is you sitting on the chair, so you're exerting a force on the chair. The reaction is the chair is countering it with an opposite force upward. So Newton's third law in nature. Consider the propulsion of a fish through the water. A fish uses its fins to push water backwards. So how a fish moves is it flaps its tail and it pushes water behind it. The reason why it moves forward is because the water is going to push with an opposite direction. So if the fish pushes the water backwards, the water has to push the fish forward. So in turn, the water reacts by pushing the fish forward, propelling the fish through the water. The size of this force on the water equals the size of the force on the fish. So the fish pushes more strongly against the water is going to push more strongly back. The direction of this force on the water was backwards, and so the opposite direction of the force on the fish would be forwards. Have y'all ever gotten in a boat and you threw something heavy off of it? You pushed it forward, and what happens to you on the boat? So the boat gets pushed back, right? So that's an example of Newton's third law. You're pushing something forward, but when you push on something, it's going to push you and whatever you're standing on backwards. So, for example, if I'm sitting in this chair and I push on the desk, the desk pushes me backwards. Now, the reason why the desk didn't move, you saw it kind of tilt a little bit, is because it couldn't overcome static friction. But the wheels on this chair are round, so the static friction is much lower, so I get pushed backwards. So if I push the desk in this direction, the desk is going to push back, making me roll backwards. So flying gracefully through the air, birds depend on Newton's third law of motion. As the birds push down on the air with their wings, the air will push back upward, making them giving them lift. So again, for every action, there's an equal and opposite reaction. Every time you interact with something, it's going to exert an opposite force on you, and they're going to be the same force. So if you were to punch a brick wall, so the amount of force impacted on your hand will be as strong as you punch. Thomas, wake up. Keep your head up. Like, lift your head all the way up, Thomas. So every action has an equal and opposite reaction. Consider the flying motion of birds. A bird flies by the use of its wings. The wings of a bird push air downwards. In turn, the air reacts by pushing the bird upwards. So whenever they do it, they turn their wings and kind of push it at a 45-degree angle. Yes, so they kind of push it down, and then they turn and push it back. Then their wings are closer together. Then they move it forward. They do it, and they keep doing like that. So really, it's pushing more back and down. Be quick. So the size of the force on the air equals the size of the force of the bird. The direction of the force on the air downwards is opposite to the direction of the force on the bird. Action-reaction force pairs make it possible for birds to fly. So there's always going to be an equal and opposite reaction. So here's another example. Baseball forces the bat to the left. That's the baseball forces the bat to the left. The bat forces the ball to the right. So when a ball comes and hits the bat, so the bat's stationary and the ball hits it, the bat's going to go to the right. The bat's going to exert a force when the baseball goes and it go forward. If you take a basketball and drop it down to the ground, when it hits the ground, it's going to cause a force on the ground, and the ground's going to have a force on the basketball, causing it to bounce back up. Consider the motion of a car on the way to school. A car is equipped with wheels that spin backwards. As the wheels spin backwards, they grip the road and push the road backwards. So if you ever look at a car's wheels, it's touching the ground and pushing toward the ground backwards. The ground pushes on the car, making it go forward. The reaction of a rocket is an application of the third law of motion. Various fuels are burned in the engine, producing hot gas. This hot gas pushes against the inside of the tube of the rocket and escape out the bottom of the tube. As the gases move downward, the rocket moves in the opposite direction. So the rocket is pushing the gases downward, and because it's pushing downward, the gases are going to push upward onto the rocket. Would you mind going to the printer and grabbing something? Alright. teacher printer. It's Friday. First of all, let me do this. This is the code word of the day. Code word is this. So it's Friday. Instead of starting the next equation, I think we all agree. Let's push it off till next week, right? Yes, we're gonna have a much more complicated equation. Yeah, sounds like a great Monday problem.